A Japanese AI lab just claimed its new model beats Fable 5, Mythos 5, and GPT 5.5 across all major benchmarks. Remember, we all had that one kid in school who claimed he could beat everyone at everything. This is the AI version of that same kid. Now, instead of jumping to a wow, what a great new AI model, I spent the last 2 days thoroughly testing it and going through every demo I could find just to dig out the reality of this mighty claim. And surely enough, the reality is genuinely different from what the benchmark numbers are telling us. So before anyone misguides you any further, let's get straight into the true facts about this new Japanese invention. So what really is this new champion AI smoking all the biggest AI models ever built? Well, the lab is called Sakana AI based in Japan, and their new system is called Fugu Ultra. And I am calling it a system deliberately because that is the first thing most of us are getting wrong about it. Fugu Ultra is not a single model. It is a multi-agent orchestration system that coordinates multiple existing AI models behind the scenes and presents the results through a single API. So when we call it, we are not talking to one brain, we are talking to a coordinator that breaks our task into subtasks, routes each subtask to whichever model it thinks is best suited, critiques the output, verifies the results, and then synthesizes everything into one final answer. Think of it this way. If we ask a single model a hard question, that one model has to do all the thinking. If we ask Fugu Ultra the same question, a coordinator splits it up, hands pieces to different specialists, checks their work, and assembles the final response. That is a fundamentally different approach from what Anthropic does with Fable or what OpenAI does with GPT 5.5. And this architecture is exactly why the benchmark scores look so impressive. But it is also why the real-world experience feels very different. And that gap between the chart and the chair is exactly what I'm going to show next. Let me tell the numbers first because they are genuinely striking before we add any context. On live code bench, Fugu Ultra outperforms Fable 5. On terminal bench, it ranks above Fable 5 and above GPT 5.5. On the World of AI Coding benchmark, it sits at the top of the chart, ranked above Mythos 5. Across engineering, scientific reasoning, and agentic benchmarks, the results Sakana published show strong performance that puts Fugu Ultra in what looks like genuine frontier territory. On SWE Bench Pro, it falls behind Fable 5 but still holds its own against GPT 5.5. So the overall picture from the benchmark charts is a model that competes with or beats the biggest names in AI. Now, if I stop the video right here, we would all walk away thinking a Japanese startup just leapfrogged every major lab on the planet. But here is the part the benchmark chart does not show us. And this is where everything changes. And as we move to the most crucial portion of the video, just hit that like button and press the lonely subscribe button as well. Here is where the chart meets the reality and the results tell two different stories at once. First test, a complete live trading desk with front-end and back-end components, real-time market data for 8 symbols, and a custom dark theme UI. Fugu Ultra used approximately 22,000 tokens and cost 51 cents. Opus 4.8 used about 16,000 tokens and cost 31 cents. GPT 5.5 used roughly 11,000 tokens and cost 26 cents. And GLM 5.2 used 13,000 tokens and cost 3 cents. Now here is where it gets interesting. Fugu Ultra actually delivered the most polished and feature-rich trading desk of the group. Strong functionality, refined interface, real attention to detail. Opus 4.8 and GPT 5.5 both produced solid implementations with a better balance between quality, speed, and cost. But the raw output quality from Fugu on this specific task was genuinely impressive. So it can produce excellent work. The question is what it costs us to get there. Second test, Clone Crossy Road, the popular mobile game. And this is where the cost problem becomes impossible for any of us to ignore. Fugu Ultra spent 90,000 tokens, cost $7.32 and took 22 minutes. But the output had inverted controls, a wonky camera system, no sound effects, and an incomplete crossroad layout. Opus 4.8 used close to 1 million tokens and cost $379, which is obviously extreme, but it delivered a more polished game with better functionality and design. Fugu was faster and cheaper on this one, but the quality gap was visible. Third test, simulate a realistic black hole. And on this one, Fugu Ultra genuinely delivered. The rendering, the gravitational distortion, every component was accurately displayed. It outperformed GLM 5.2 and Minimax on the same prompt. When the orchestration system has time to coordinate properly on a contained, well-defined visual task, the results can be genuinely strong. Fourth test, build a flight simulator with infinite terrain generation. Fugu Ultra produced a working simulation with accurate terrain, a semi-realistic flight model, and proper environmental rendering. GLM 5.2 failed the generation entirely. Minimax produced a plane but no actual simulation. Fugu won this one clearly. And then there is the blindfold chess test, which is the single most impressive demo Sakana showed. 4 back-to-back games against 3 Frontier models and a 2100 ELO Stockfish engine, all played without seeing the board, maintaining the full game state from memory. Fugu stayed accurate while the other models drifted, and it won every game. That level of sustained state tracking across multiple games is a real capability demonstration. So the pattern across all of these tests is clear, but we really need to know what I am going to tell next, the truth. So can you guess why the benchmark numbers are so outrageous? Well, the reason Fugu Ultra scores so well on benchmarks is the same reason it struggles in real-world use. And once we understand the mechanism, the whole picture flips. On structured benchmarks that reward careful checking and step-by-step problem solving, orchestration systems have a natural advantage. The coordinator does not need to be frontier-level intelligent itself. It just needs to be good at decomposition, routing, verification, and aggregation. It breaks a benchmark task into pieces, hands each piece to the best available model, checks the work, and assembles a clean answer. That process naturally produces strong scores on benchmarks like Live Code Bench, where structured, verifiable outputs are what get graded. But the same strategy becomes a disadvantage on long-horizon agentic tasks. Every extra planning step, every verification pass, every model handoff introduces latency, cost, and additional failure points. This is why SWE Bench Pro, which tests sustained autonomous work across complex code bases, exposes orchestration-heavy systems compared to native frontier models like Fable 5. So should we trust the scores? Partly. The scores themselves are measuring real performance, but they are measuring the performance of an entire orchestrated system, not the intelligence of a single model. That is a very different thing from claiming the underlying capability is comparable to Fable 5 or Mythos 5. And the real-world tests prove this more clearly than any benchmark caveat could. So here is the honest verdict, which most of the channels are afraid to admit. Well, based on my 20 years of AI experience, I can tell that Fugu Ultra is genuinely impressive as an engineering achievement. The orchestration system can produce standout results on specific tasks, especially structured benchmarks, contained visual generations, and state tracking challenges like blindfold chess. When it has time to coordinate, decompose, verify, and synthesize, the output can be excellent. But in real-world usage, it is often slow, relatively expensive due to the orchestration overhead, and inconsistent on difficult practical tasks. The Crossy Road test showed inverted controls and missing features. The front-end generations appear to route to GPT5.5 under the hood for most of the actual code writing. And the cost per task, while sometimes competitive, can spike dramatically depending on how many orchestration passes the system decides it needs. And I say this knowing some of you watching might disagree with me, but this channel does not pick favorites, it picks facts. The honest comparison is not Fable 5, it is GLM 5.2. In overall real-world capability, Fugu Ultra sits much closer to GLM 5.2 territory than to Fable or Mythos. And GLM 5.2 does similar front-end work at 3 cents per task versus Fugu's 51 cents. The beats Fable 5 and Mythos 5 framing from Sakana is technically accurate on specific orchestrated benchmarks. It is misleading as a general capability claim. Beating a frontier model on a benchmark that rewards decomposition and verification is not the same thing as being a frontier model. But here is why I think this matters anyway, and this is the part I do not want any of us to miss. Well, both Fugu Ultra and OpenRouter Fusion are pointing in the same direction, and that direction is genuinely important even if neither system is a Fable replacement today. The idea that we can take several non-frontier models, orchestrate them through a smart coordinator that decomposes tasks, routes them, verifies the work, and synthesizes the results, and get output that competes with or beats a single frontier model on specific tests. That idea is now proven by 2 completely independent systems in the same month. OpenRouter did it with Fusion, Sakana did it with Fugu Ultra. Both arrived at roughly the same insight. We do not need one massive brain to produce frontier level output. We need several good brains and a smart judge. The implication for all of us is significant. If orchestration systems keep improving, and if the coordinator layer gets smarter about when to route and when to verify, the gap between these systems and true frontier models will continue to close. Not on every task, but on enough tasks that the pricing pressure alone forces the frontier labs to respond. That is perhaps why the reality being different from the benchmark does not make Fugu Ultra irrelevant. Rather, it is a signal of where it all is going. So here is the honest picture. Sakana Fugu Ultra beats Fable 5 and GPT 5.5 on several benchmarks. That is real. But it is an orchestration system, not a single model, and in practical use, it sits closer to GLM 5.2 than to Fable. It is slower, often more expensive, and inconsistent on long horizon tasks. What it does prove is that smart orchestration of existing models can reach benchmark scores that compete with frontier intelligence. And that is genuinely worth all of us watching, because if this approach keeps improving, the whole pricing model of frontier AI would change. By the way, has any one of you tried this new Japanese AI, or are you happy with the conventional AI we all are using? And which one is your favorite AI? Do share in the comments. Subscribe to my channel as I cover every major AI release with a completely honest and unbiased view. I'll see you in the next one.